with lesson 2 for year 13 physics, and this lesson is a brief on the oscilloscope and moving on to AC in a pure resistor. So the oscilloscope is an instrument that displays an AC voltage across a component. It is a meter that draws a voltage time graph, and it has a grid as a background, and there's controls to adjust the scales. So the x-axis represents what we call the time-based setting, and the y-axis is what we call the y-gain setting to read off the voltage. Kind of get like a sine curve, and you can choose and move things around in an oscilloscope. Now, impedance. Now, whenever there are components in any circuit, they go to limit the current. So in an AC circuit, the amount by which a component limits the current is called impedance. The symbol Z is a Z. Now, the impedance of a resistor is called resistance. If you have a capacitor or an inductor in an AC circuit, then the impedance of those are called reactance. The symbol for impedance is reactance is X, and you put a C if it's a capacitor or a subscript L if it is an inductor. The unit for all of them is the ohm. Now, moving on to AC in a pure resistor. Resistors are the only components that convert electrical energy to heat energy. The current through and the voltage across the resistor are in phase. That means when the current is a maximum, the voltage is also a maximum. And the current and voltage are also in phase with the supply voltage and current. Now, the resistance of a resistor is not affected by the frequency of AC. You can use Ohm's law for a resistor, whereas V equals IR, but just be careful that you don't mix up RMS and peak values. If it's RMS, then both these should be RMS. If it's peak, both the voltage and the current need to be a maximum or peak value.